Start recording. Okay. So starting with number 5, a substance which produces hydroxide ions in solution, that anything that that is the same as releases OH minus ions in solution, that is an Arrhenius base. Okay, that's just a definition and you need to know that. Okay, an Arrhenius acid would release or produce hydrogen ions in solution. Okay. Number 10. The formula for a salt is simply an ionic compound. What do all ionic compounds start with? Start with a metal. Or what's the other thing they can start with? There's another positive ion. No, those are going to be acids. That is another positive ion, but those ones will be acids. You guys should know this one. Ammonium, NH4+. Okay, so that's how you know you have an ionic compound. You should also know that compounds are electrically neutral. Okay, so if we go through our list here, we can see that this is an acid. This is an acid because we have that COOH at the end. And that leaves us with the Na2HPO4 and the CuNH342+. Because it is a compound, it should be electrically neutral, which means that that one has a 2+ charge, so that one is no. This one is electrically neutral, so that one is yes. Okay, number 22. Okay, the pH of 0.0025 molar lime water. I was surprised that so many people asked me about this. I got so many in here and so many in my other block because you did a question exactly like this on that practice quiz, and then you marked the practice quiz. And yet so many people originally got C here. What type of a compound is CaOH2? That is a strong Arrhenius base. All metal hydroxides are strong Arrhenius bases. And from that, you can tell that it should be either C or D. So if you have no idea what you're doing, at least you've got a 50-50 chance of guessing correctly. Yes? But if we look at Ca, OH2, what does a strong Arrhenius base do? It dissociates how much? 100%. Okay, so if we write the dissociation for calcium hydroxide, what do we get? What are the two things we get? We get calcium and we get hydroxide. Okay, now as that's written, that's not correct. What is the charge of calcium? If you forget, you can look on your periodic table. It is in column number 2. Therefore, it is 2 plus. If you forget even how to do that, it is in the table of common ions in the positive ion section. OH is -1. Is this it? No, because we have a 2 here, we need to have a 2 here. And if this solution is 0.0025, we have a 1 to 1 to 2 ratio. So the calcium will be 0.0025 and the hydroxide will be 0.0050. It's going to be twice as much, right? Because it is the 2 here. And so then if we take the negative log, why it keeps moving on me? That's so weird. 0.0050. Do you see how it's like jumping down? Like is no, and it's very weird. Okay. Okay. It's trying to line it up for me or something. But anyway, so then we get, no, it's not. It's just doing crazy things. I may have to close this and open it again to get it to stop doing whatever it thinks it's doing for me. So if we take the negative log there, we get 0.005 log 2.3. And then we get 14 minus 2.3 is 11.7. And I'm going to close this and open this again because this is going to drive me bananas. Okay, so let's try closing this. Oh yeah, it's having issues. Look at that, it won't close. It's thinking really hard. Okay, let's close this. Let's close this. Let's close that. Okay, let's not have too many things open so the poor little brain of the computer doesn't freak out. Okay, fingers crossed. That's gonna work for us now. So that was number 22, 11.70. Number 29, 29. Water at 25 degrees Celsius has a pH of 7. And the equation for dissociation is like that. Our heat term is here. So at 80 degrees Celsius, we have gone from 25 to 80. So we have increased the temperature. If we increase temperature, the system will shift to the right. To absorb the extra heat. And so we are, what happens to the concentration of H3O plus? Concentration of H3O plus increases, and concentration of OH minus increases. Yes? So if they both increase by the same amount. Yes? And if they both increase by the same amount, are we acidic, basic, or neutral? We are neutral. And if hydronium increases, what happens to our pH? Our pH decreases, so our pH will be less than 7. The pOH is also less than 7. Neutral, and that means neutral pH at 80 degrees is less than 7. Aha. Number 31 looks really hard, but it's actually not, because you can just go look it up on your chart. Because we've got this weird thing. We've got AlH2O63 plus. So we can go to our data booklet and we can look up AlH2O63 plus. It is right here. So what is its conjugate base? That is its conjugate base, because the conjugate base is always on the other side. Yeah, so you don't really, we will learn about that particular structure and how it works in Unit 5, but for this unit, all you need to be able to do is like look up its conjugate base. And if you're wondering how we got that, what happens is you have 6 waters attached. One of those waters gives up an H plus and becomes OH. So one of the waters becomes OH, and you're left with 5 waters, and it gave up an H plus, so it becomes a 2 plus charge. But easiest thing is to look up in data booklet. Okay. Number 32. Which of the following will have the greatest concentration of hydronium? The strength of the acid matters more than the concentration. Because, for example, with HNO2, we mostly have HNO2 and only a very little bit of the H plus and the NO2 minus. So we'll only a little bit is dissociated because it's weak. Another one that is weak is here. Okay, so that one is also weak. So again, we have lots of HCN and only a little tiny bit of H plus and CN minus. So again, not much because it's weak. Now with HCl, HCl is strong. HNO3 is also strong. Okay, so we have HNO3 goes to H plus and NO3 minus. This one goes to H plus and Cl minus. For this one here, now they're both strong, so now we can look at the concentration and compare. This one is 0.15 molar, so the hydrogen ion concentration is going to be 0.15 molar. The HCl is 0.1 molar, therefore the H is going to be 0.1 molar, and therefore that's going to have the highest concentration of H. So eliminate the 2 weak acids right off the bat, and then the 2 strong acids, it depends on their concentration. Number 41. Which of the following reactions will favor the reactants? If we want it to favor the reactants, where does the weak acid have to be and where does the weaker acid and where does the stronger acid have to be? The weaker acid and the stronger acid. The stronger acid should be in the products because it's going to push towards the reactants, and the weaker acid is going to be in the reactants. So what we're going to do is we're going to identify the two acids in each equation and compare their strength. So in this first one, HF is giving a proton. So this is our acid, and this is our acid. This one's easy because we have, that's an acid and that's an acid. They're the only ones with H. These are the only ones with H, and these are the only ones with H. So we want something where the stronger acid is in the products. So now we need to go and look things up. I know for a fact that H2S is one of the weakest acids. So this one's weaker. So I'm not even going to go look it up. You can go look it up. This one's stronger. So it's not A. Water, I think, is the weakest acid. Let's go look. Yes, it is. So that means HF is stronger. So it's not B. Now we should look up HF and HSO4. Let's go see that one. HF is here. HSO4 is here. So HSO4 is stronger. Oops. That's not what I wanted. There we go. HSO4 is stronger. HF is weaker. So our answer must be C. We don't even need to look at D because we found our answer already. But if you were to look at D, you would find that acetic acid is weaker than HF. Let's just confirm that. Acetic acid is here. And indeed, it is weaker than HF. Okay. And by the way, if I'm going through any of these and you've got questions about them, don't hesitate to stop me. Okay. Number 44. Consider the following equilibrium. We have the HOI and F minus, and we are told that the reactants are favored at equilibrium. I'm guessing one of the reasons people don't like is they're like, HOI is not on my table. But we don't need it to be on our table because we are told that the reactants are favored at equilibrium. And which side is favored, the stronger side or the weaker side? The weaker side is favored. And that means that this is your stronger acid, and this one is your stronger base. The two stronger things are always on the same side. The two weaker things are always on the same side. So we would have HF and OI minus, there we are. Number 48. In which of the following is HSO3 acting as a Bronsted-Lowry acid? So we need hydrogen, we need HSO3 to be giving a proton away. And if it gives an H plus away, it becomes, what does it become? It becomes the Bronsted-Lowry base. What is the formula for that Bronsted-Lowry base if HSO3 gives away a proton? SO3 2 minus. So we are looking for SO3 2 minus in our product, and it's right there. And actually, you could do that one. You guys probably don't know this, but when I was a little girl and I watched Sesame Street, there was this little song, and it said, 3 of these things belong together. 3 of these things are kind of the same. 1 of these things just doesn't belong here. That's how we play our game. That's how we play our game. Okay, and do you see how in our products, we have 3 of these things belong together. 3 of these things are kind of the same. 1 of these things just doesn't belong here. So you can, if you really have no idea about a question, sometimes you can play that game. Yes? Okay. So that's our answer there is B. Number 50. Which of the following is correct if the 4 solutions are compared to one another? So we have the first 2. We have, compared to one another. Okay, so we have a strong acid and 1 molar. So that means the ion concentration will be the greatest. Because if we had a weak acid, the ion concentration is much lower because it's not dissociated. Okay, our weak base would be much, much lower. And that's because it has both a lower concentration, it's only 0.5 molar, but also it is a weak base, therefore it's mostly unionized. Not unionized, unionized. Probably a more efficient way to go about this question, now that I'm looking at it, would be to say, weak, ionization is not complete. Ionization is not complete, right? That would be a really efficient way to go about doing this question. And then you could say, out of my 2, my strong acid and my strong base, they both have complete ionization, so that part is correct. But because this one has a lower concentration, it will have not as many ions as the strong acid. I went a long way around to get there. Okay, so the answer is A. That is the correct statement. Number 54. Which of the solutions will have the lowest electrical conductivity? So we are looking for something that is weak, yes? And HI is a strong acid, so that's not it. H2SO4 is a strong acid, so that's not it. H2S is a weak acid, so that's probably it. Let's just look at our last one, NaNO3. Sometimes people are like, well, that's not an acid, so it doesn't conduct, but acids conduct, bases conduct, and what else conducts? Aqueous acids conduct, aqueous bases conduct. What else produces ions in solution? There's acids, there's bases, and there are salts. Salts conduct. Why do salts conduct? Because salts, what are salts? Ionic compounds. And what do ionic compounds do in solution? They dissociate to give ions. And here we have sodium. Na plus is an alkali. What does that tell us about this particular salt? Yeah, it's soluble. Plus, we don't even need to look that up because we are told it is 1 molar. Yes, which means it is soluble. Yes. So this would dissociate into Na plus and NO3 minus. So lots and lots of ions. So it's going to be H2S that doesn't dissociate very much. That is our lowest. Strong acid dissociates completely. Strong acid dissociates completely. Soluble salt dissociates completely. So they would all have the same ion concentrations. Number 56. So, sorry? So there's 2 answers for 54. What? We want the lowest electrical conductivity. This dissociates partially. Therefore, low ion concentration. So your answer is that one. The rest of them, they all dissociate completely. So you would have here 2 molar ions, 2 molar ions, 2 molar ions, right? Because you would get 2 ions for every particle. Does that make sense? Cool. All right, number 56. Which of the following factors of an acidic solution would affect its pH? Does temperature affect the pH of an acidic solution? Yes, because it affects the K, okay? Does the strength of an acid affect its pH? Yes. Does the concentration of an acid affect its pH? Yes. So that would be D, 1, 2, and 3. Number 70. 70. All of the following can act as Bronsted-Lowry bases except, so what is a Bronsted-Lowry base? Yes. Yes, thank you. What is a Bronsted-Lowry base? What's the definition? Huh? Yeah, it's a proton acceptor. So what that tells us is that 4 of these can accept protons and 1 cannot. So, is it possible for NH3 to accept a proton and become NH4? Yes. Is it possible for OH minus to accept a proton and become H2O? Yes. Is it possible for H2O to accept a proton and become H3O plus? Yes. Is it possible for Cl minus to accept a proton and become HCl?
Technically, it's good, but the problem is that
So it could not happen then. Yeah? Because when you have a strong acid,
oh, it goes
right? It cannot go in reverse. So if I was to take Cl minus plus H plus, I would get no reaction. So the answer then is D. The other way to look at it is to go to your chart and say, we have NH3, hey, why are you not doing things? Yeah, okay. Okay, so 2 of the things we had were NH2 and OH, and we were given NH3. NH3, where did you go? There you are. And water, which is way up here, and Cl minus. And once again, you can play 3 of these things belong together or not. 4 of these things belong together in this case. Everything is on the base side, but everything can go backwards except this one cannot go backwards. No. Yeah? Okay. Yes. You would say that HCl is a strong, HCl is a strong acid? Hopefully, at this point, yeah. If not, you can check the table and say, oh, HCl is a strong acid. The conjugate acid is strong. Therefore, its conjugate base cannot be an acid. Yeah. Okay, 17. 81. No, not 81. Sorry. 83. at 298 Kelvin, pure water has a KW of 1 times 10 to the negative 14. Okay, if that's the case, what temperature are we in Celsius? KW is 1 times 10 to the negative 14. We're at 25 degrees Celsius. So if that makes you more comfortable, you can just say 25 degrees Celsius, 25 degrees Celsius, and 25 degrees Celsius. So if it's the Kelvin that's messing you up, don't worry. I'm not going to give you Kelvin on your test. This is an AP question, as are all the ones from number 65 onward, but there's a lot of overlap between regular chem and AP chem in this unit in particular. So other than the fact that this has Kelvin in it, is a perfectly acceptable question. Okay, for regular chem 12. If this is true, is it true that pure water has a pH of 7 at 25? Yes. Is it true that OH minus is 10 to the negative 7? Yes. Is it true that hydronium is 1 times 10 to the negative 7? Yes. And therefore, all three of them are true. Why did we do 82? I don't know. We were supposed to do 85, but that's okay. We've now done 82. A little bonus for you all. Okay, a solution with a volume of 1 liter has a pH of 3. What volume of water must be added to the solution to raise the pH by 1 unit? Okay, so we have 1 liter of solution, and the pH is equal to 3. What is our hydrogen ion concentration? Yeah, 10 to the negative 3 molar. Now we want to add some water. Okay, we don't know how much. 1 liter plus some amount. And we want that to give us a pH. We want it to raise the pH by 1 unit. What will our new pH be? What will our new pH be? If we raise it by 1 unit? 4. Okay, which means our new concentration is 10 to the negative 4 molar. Yeah? So this is how many times less concentrated? We have changed by a power of 10. Therefore, this one here is 10 times less concentrated. So what does our volume have to be? How many times bigger does the volume have to be? The volume must be 10 times bigger. So what's our new volume? We started with 1 liter. We're now going to have 10 liters. And we're asked how much water we needed to add. So that's going to be 9 liters. Yeah? Number 89. Oh, this might be due to this one might be due to the 298K. 25 degrees Celsius, number 89. So if we have a concentration of OH minus of 1 times 10 to the negative 6 molar at 25 degrees Celsius, is the solution neutral? at 25 degrees Celsius. Is this acidic, basic, or neutral? Acidic, basic, or neutral? Yeah, the concentration of OH minus is greater than 1 times 10 to the negative 7. So therefore, it's going to be basic, and therefore our answer is B. I apologize for that Kelvin there. I'll have to fix that. All right, number 92. The pH of a 0.1 molar solution of a monoprotic acid with a Ka of 1 times 10 to the negative 7. Now, because this is multiple choice, I wouldn't even bother with a rice table. Yeah? Normally, I would do a rice table. Yes, for a question like this. But because it's a multiple choice, I would just be like, Ka is equal to x squared over 0.1. Okay? Now, if you cannot see that, if you're like, where, how, what, then do a rice table. Yes? Okay? Multiple choice, you can just do. Okay, but if you're like, I don't know how you got that, you can say, we got HA, H plus, A minus, 0.100, X minus X, 0.1 minus X, X. Assume X is much less than 0.1, and then you would have Ka is equal to H times A minus over HA, which gives you that, x squared over 0.1. But for a multiple choice question, you can just like go right to there and be like, okay. So you would do Ka is 1 times 10 to the negative 7 times 0.1 equals x squared. So x squared is equal to 1 times 10 to the negative 8, which means that x is 1 times 10 to the negative 4, which means the pH is 4. So even though that looks like it's a big, long question, it's really not, because the math is all stuff you could do in your head without crunching numbers in, because they're all just powers of 10 with a 1 in front of them. The pKa of a weak acid, number 93. Anytime we want to find a pKa is equal to the negative log of Ka. So that's going to be the negative log of 1 times 10 to the negative 8, which is 8. Is this helpful? Yeah? Okay. 94. Here we have acids listed in order of increasing Ka values. So is it true that HCN is the strongest acid? So this is Ka big, this is Ka small, because we're listed in order of increasing Ka values. Is HCN the strongest of those acids? No, because it has the smallest Ka value. No. Is CN minus the strongest conjugate base? Well, if it was the strongest conjugate base, that would mean that HCN was what in terms of the acids? Does the strongest acid have the strongest conjugate base? No. HCN is the weakest acid. Yes, because the stronger the base, the weaker the conjugate acid, and vice versa. Stronger the acid, the weaker the conjugate base. Ca, conjugate acid, Cb, conjugate base. Okay. And then finally, the reaction below has an equilibrium constant greater than 1. What does that tell us? If it's greater than 1, who is favored? Products favored. And in this case, our two acids are here and here. HCN is the weaker, and HCOOH is the stronger. So who's favored? Reactants are favored. So is it true that the equilibrium constant is greater than 1? No, because that would mean the products were favored. So this one is not true. This one is not true. Is it true that HCN is the weakest acid? Yes. So that's going to be number 2 only. You can ignore number 95, and now we're going to try 96. Which of the following expressions shows the correct setup for calculating the acid dissociation for ethanoic acid? So ethanoic acid is CH3COOH in equilibrium with CH3COO minus and H plus. Now, once again, you know that Ka is equal to x squared over the concentration of the acid, yes? And if you don't know that, you can do a rice table. And you can just be like, okay, I don't know what the initial concentration is for this one, so I'm just going to call it 1. Yeah? Plus x, or sorry, 0, 0. Plus x, minus x, 1 minus x. Let's get rid of that. Hi. Oh, I'm not here today. Thank you. Okay, and so we're going to end up with x squared over the concentration of CH3COOH. So, what is x? X is hydrogen. What else is x? CH3COO minus. These two are the same. So rather than writing Ka equals H plus times CH3COO minus, I feel like I went about this the long way. We could have just started here. COOH. At equilibrium, these two are equal, and so you can substitute H for COO minus. And if you substitute H, you get H squared over COOH. Yeah? Yeah, I don't know why I went about it the long way, but that's okay. Number 97. Which of the following equilibria lie heavily to the right side? Okay, so we need, if we're going to lie heavily to the right-hand side, what do we want on the right-hand side? We want the weaker acid on the right-hand side. Okay, so we have HCN and H2O. HCN and H2O, nope. Oh, our weaker acid is on the right-hand side. No, it's not. Weaker, stronger. We have HCl and HCN. This one is stronger. In fact, it is strong. Weaker. So if it's going to lie heavily to the right-hand side, I would say the one with the strong acid is going to lie the most heavily to the right-hand side. This one is missing a minus here. Fix. Okay, but this one is a one-way arrow this way because NH2 is a strong base. HCl is a strong acid, so it lies completely in the reactants. There's no products. And just to confirm, this one is weaker and this one is stronger. So again, that's in the reactants. So it's really only C, but by the time you've gotten there, you don't have to look at all the other ones. You can just say, oh, there's my strong acid on the left. Therefore, it has to go to completion. Therefore, it lies heavily to the right-hand side. All right, we would like to go over written response number 7. Oh, this is a nasty one. So much fun, right?
Twice as much conjugate. You have 2x bases, so you have 2x acid.
Twice as much conjugate base as acid. So which one is more? Yeah, no problem. Which one is more?
Bases are acid. Like
it contains twice as much base. Therefore, is there more base or more acid?
Base.
More base. Less acid.
So acid is base.
Yeah, so this is going to be X, this is going to be 2X. So we have now this unknown acid. It is a monoprotic acid. So let us go with HA in equilibrium with H plus and A minus. Let's do a race table. And we have twice as much conjugate base as acid. So this is going to be 2X at equilibrium. And this is going to be X at equilibrium. And if HA is, or sorry, if A minus is 2X, then H is also 2X.
Would you know the H though?
And we know the H. Yes? So concentration of H is equal to 10 to the negative pH, which is 10 to the negative 4.20, which is 4.2 negative inverse log, anti-log, 6.3 times 10 to the negative 5. And that is equal to 2x. And we're asked for the Ka value. So the Ka is going to equal H plus times A minus over HA. So that's going to equal 2x all squared over x. And so that's going to equal 6.3 times 10 to the negative 5, which is 2x all squared, divided by, and then we need an x, so that's going to be 6.3 times 10 to the negative 5 divided by 2. So let's square that. Let's memory in. Memory in. Hi. What we got? Okay, Remy's here. Yeah. Oh my God, we got so many. Coco's here, Sambed's here. Tabrim is also here again, and Fiona is here. Okay, thank you so much. All right, Fiona, Tabrim, I got 2 for you. You're special. Look at that. And Coco and Fiona. And Sambed.
But the send it digit. Yeah, and think of no, you back after.
And when I do the math on that, I get 3.155 times 10 to the negative 5, but we only want to have 2 sig figs. So that's going to become 3.2 times 10 to the negative 5. Is good?
Yeah.
Okay, cool, cool, cool. And that is all you guys asked for. Would you like me to do any of the questions that my AP guys asked me for last semester? No, we're done? Do we feel like we've done enough?
I don't really understand.
57? Let's do 57.
Yep.
Okay. What happens to H3O plus and pH when we add NaOH? Now, if we add NaOH, what are we really adding? We're really adding, yeah, Na plus and OH minus. Do we care about the Na? Or is Na a spectator? Na is a spectator. Because what would it react with? Yeah? Heda, could you close the door, please? Thank you so much. Na is a spectator, so we're really just looking at hydroxide. So therefore, the concentration of hydroxide has increased. Okay, so what's going to happen is that the hydroxide is going to go up, which means we're going to shift to the left. Yes? Now, if we look at our concentrations, if we were to draw a concentration diagram, H3O plus, and this is OH minus, and H3O plus, start out the same, right? Because it's pure water. And OH concentration goes up. Yeah? And then as we shift to the, I don't want it to go up that much. I'm going to run out of room. I'll just make it go up a little bit. There we go. As we shift to the left, the hydroxide ion concentration is going to go down. It never gets quite to where it was. And the hydronium ion concentration is also going to go down. Yeah, so H3O plus decreases, therefore pH increases. Yeah. Yeah. Anything else? Do you guys want to get your new book? Pardon me? We just have a break. I mean, I feel like we've worked hard this class. Does anyone want me to go over any of the other questions? No? Okay. So if you have questions tomorrow, you can drop by during Flex. I don't think we'll do another one of these tomorrow because that sounds crazy. Yeah? So if you have questions tomorrow, drop by either lunchtime or Flex or something like that. Yeah? And we'll just be done for the day right now. Have a breath. Roll your shoulders. Oh, that feels good. Oh my God. It's too bad that the massage circle thing is kind of cringy because it really feels good. But I don't want to ever do that. That's why I like it when my son's at home because like we'll massage each other's back. Yeah. My dad and I do each other. Your mom what? Oh yeah. I'm like, just
And last year, like in December, how much December like the cold season. You can like a bit. Well, everyone. from here upstairs. She was supposed to get the way all the I think she was in the one from she was doing so much right now. Then she was like, oh my gosh, I'm gonna get off there. And she took some bio and yeah, so I know so yeah. Yeah, look at not wrong. Oh, she like gets off. Yeah. Within 2 weeks. It's the oxygen. Is it? No, this was better. No, she like the body. Oh yeah, oh yeah. Yeah. We don't want to. Then so what? No way. No, yeah. Right. She was like, actually, you know what they done? And she what? Yeah. Why? Very not. Yeah, those are definitely not. So anyway, so yeah, she's definitely get plugged, and yeah, you don't have to. Because you have to do grass and stuff. It's super terrible, blah blah blah. She was not confident at all, and then she started. She murdered people from the putting her up. Where's that? Like, yeah. But they were really solid, you know. Sometimes that happens. I have you don't want like and she like I really is not integrated. Because I told you I never take it first. Because of the teacher, take it like you can take it because the teacher if you're also interested in it. Like she ended up glaring at me every time she goes. I know she's not taking the play off with. There's several exams. Oh, that's a good one. Exam and AP exam. So one of the rules because it's just a big. Like it's just so much. There's just so much in it, and you need to know so much. Physics is the hardest in terms of the actual understanding. Yeah. Yeah. So physics is the hardest. Chemistry is the hardest. Really much to know. Yeah, it's like yeah, right. And then okay. So back in the day, they were not because what is not like. Oh, okay, right? Like I'm like, so you guys have like the other dimensional exams, yeah. I mean, it's scholarship exams. They were just a little bit harder. They were okay. It is, but I didn't sign up because this was like back in the day. It's like a paper, and it was like, oh sure, I'll take the biology exam. And you sign your name on a piece of paper, and then they came around, you take primary. And then the day came around, I was like, I'm doing student test today. I'm not even doing lab and studying, so I'm not studying it right. It's like not. Whatever. It's exactly. You guys. Oh, yeah. He did have his lunch today. No, that's fine. My you know. Like a library, like a university library, yeah, 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 yeah. But I remember in grade 10, object some sort of application, right? And everybody did skydiving, building skydiving. First, that's what we did. Anyway, I decided to do different. catalog and look things up and maybe get a, like the one book on that subject. And that was it. That kind of like might peripherally attach you. Yes. Maybe. Exactly. It was I'm not. Yeah. But still, no, like, yeah. And you would be like, well, it's my know. And you start. And then you find it, and then. No, but the film, like, that's what essentially, you know, yes, yeah, people be like, yes. Actually, and like, oh, yeah, but for like. Then they. Then the best talk is in the middle of there's no sound about beauty. So I like research and stuff like that. Yeah. Yeah. I think it might have been maybe what I would. Yeah. No, it's just like not to have it. It's like yeah. You could like it should fit. It should absolutely fit. Oh no, we just do not want to do it. And I'd be like, settle down. This is what it was not. Hey, what was the match? We still have that. You don't have that. Right? Element. Exactly. Right? So I was like, okay, like just settle down and do it. Yeah. 10 minutes. Or you can spend 20 minutes on the bed and then 10 minutes. Why would you think about the like it's just temperament. Yeah, exactly. Exactly. Yeah. It was just like I watched you sing. Yeah. I see it. And there were fights. Oh my god. Yeah, just like not about how smart you are. No, exactly. Yeah. I don't know how you're sitting there. Yes. Yes. No, because I'm just very lucky. My temperament is like this. I'm very cautious. I will stick with things. Yeah. Like, yeah, I call it bloody minded. That's one of the words, right? Bloody minded. You must stick with it. Don't hang on to that. That's just. Right. I don't think it's anything like that. Yeah. So, yeah, I gave you some time. Yep. And I tell her saying that loving this, that bloody mindedness is a superpower. Why? Alrighty, do you feel soon? Yeah. Is it relaxing? Why don't you have the whole a little bit? Yeah, like I how many people you have? We always. Yeah. That. Like 6. Okay. So maybe like